Now, back in the dark and distant past, before everyone had a really nice calculator, then people were first forced to calculate logarithms using log tables. And I've just recreated a little part of one here for you. So here we've got kind of the normal numbers on the left from 1 up to 10. And then we've got the logarithms in base 10 in this case on the right. So the log in base 10 of 1 is 0, log in base 10 of 10 is 1, and then all the numbers in between have been calculated for you to 3 decimal places. And obviously nowadays we can use our calculators to do a lot of the stuff I'm about to show you, but I do think it's really useful for thinking about logarithms and understanding how they work, so we are going to be using them to a certain extent. Okay, so the log in base 10 of 2 is 0.301, rounded to 3 significant figures, etc. So I'm going to do 3 different things today. So first of all, let's just do a little internal check. So we're going to be using those laws of logarithms we just discussed to do what we like with these numbers, to manipulate them. So first of all, let's just check that everything's alright. So the log of 4, we'd say is equal to, we know that that's the log of 2 times 2, so that's the log of 2 plus the log of 2. So then if we look at what is the logarithm of 2, that's 0.301, as I just said, plus 0.301. That gives us 0.602, and that is in fact what it says for logarithm of 4. Good, and we could do that for any other combinations of numbers that we've got on there. But then we can also use this to look at numbers beyond this range, so 1 to 10. So smaller or bigger numbers. So for example, if we wanted to know what is the logarithm of 50, so that is equal to the logarithm of 5 times 10. So that's the log of 5 plus the log of 10. So log of 5 is 0.699 plus log of 10, which is 1. So that's 1.699. Similarly, if we wanted to know the log of, for example, 0.4, that is the logarithm of 4 divided by 10. So that's the logarithm of 4 minus the logarithm of 10. Log of 4 is 0.602, we've just established, minus 1. So that is, let me just calculate that, 0.602 minus 1, minus 0.398. And then how about logarithm of 0.0004, a number that's much smaller, so that is equal to 4 divided by 10 to the 4. So that's log of 4 minus the log of 10 to the 4. So log of 10 to the 4 is 4. So that's 0.602 minus 4, so that's minus 3.398. So you'll notice that this 398 is the same for log of 0.4 and the log of 0.0004. That's an interesting point we'll come back to. And then the final thing we can do is use a log table to calculate logs in a different base. So let's imagine we didn't have a calculator and we only had this table and we wanted to know what is the log in base 2 of 7. So we could use the formula that you've learnt to work out that it's the log in base 10 of 7 over the log in base 10 of 2. So log of 7 is 0.845, log of 2 is 0.301, so then we can just divide those, and that is equal to 2.807, which makes sense because that's in between So 2 squared is 4, 2 cubed is 8, and so and 7 is in between 4 and 8. And so I like that answer, it makes sense to me. Okay, so these are the two main things you can do. You can use the log table to calculate any number you like by multiplying and dividing these different numbers. And so it doesn't have to be within this range. You can multiply and divide them, and you can also use it to calculate logs in a different base.